Hi, welcome back. This video is a supplement to 08 BIM Measurement 2, whereby I showed you how to utilize model map functionality in CostX. This one is a little bit more advanced because we're using some functions that you mightn't have come across before. One very useful function that I use time and time again is the XNUMBER formula. Now this XNUMBER formula is the same as what you'll see in Excel in terms of getting a specific number from a string of text or a string of numbers. We're just utilizing it in the mapping definitions to take a particular number from a parameter. So going back to CostX, I've already set up a structural steel, what's coming up there, structural steel model map. I'm going to scroll down to have a look at what kind of structural steel we have in this particular model. Not a whole lot. Structural framing, we got some girders or trusses, and we got basically some structural steel around the perimeter of the roof. For example purposes, I'm going to just select that universal beam. Now there is only one type of steel, it's a UB. If I scroll across my schedule here, I can see it's a universal beam, the family name, and my level names, universal beam level 3, which is the most important one here. It's a 305 millimeters high. Just zoom in there for you a little bit. That's the height of the web. 165 millimeters wide, the height of the flange, and very importantly, showing you or illustrating this XNUMBER feature, the 40 kg, even though it doesn't say it there, the last number is 40 kg per meter of this type. So you'll see different last numbers there with respect to different sizes of steel. So to set this up, I'm going to scroll across. I'm going to use the comments parameter. Again, that depends on where you input that information. I showed you some additional videos where you might put it in the assembly code or in the keynote, or it could be even a user-defined parameter, specifically called, in this case, National Standard Building Elements. So that's the folder name. What I always find it quite useful doing is flick between preview and mapping definition occasionally as you're carrying out your mapping definition. And if you do so, you might see that you've made an error and be able to change that. If you don't, you could have made the error, but you don't know where because you weren't checking it incrementally. To create a dimension group name, again, I'm going to utilize my parameter headings here. Let's say I take, if I scroll across, the level 2 heading, and I add in plus. Again, I'm going to show you to a few dashes, add in another string of text. So again, by doing that, which I showed you before, quotation marks, a bit of text, or even it could be just spaces, close quotation marks, plus again, and drag and drop over the actual size of steel. So again, preview, we've got a nice little bit of space with a couple of dashes in there. Universal beam 305 by 165 by 40. Okay, let's populate some of these fields. Again, what dimensions do we have here? We've got a volume, even though I really don't need volume for steel. I'm going to drag and drop it over. Scroll across, it's in alphabetical order. Length, drag and drop the length into length. It's already designated as millimeters here, so I don't have to worry about mapping that as a unit. It's already there. And I also have, if I scroll across, a parameter or a heading called cut length. So what's the difference between cut length and length? If I just click, the cut length is essentially the actual length from, in this case, from the inside of the flange there on the column in terms of the beam over to the other side, to the inside of the flange of that column. The length itself is really a nominal length, and it includes kind of a center to center calculation there. So if I scroll down, you'll see that the length will be from I suppose one center of one column in terms of the beam length to the other center of that particular column, whereas the cut length stops at the actual flange connection. And it may even be an offset, which there is here, which may be used for a space for your plate or your bolt connection, or whatever it is that connects those two members together. So the cut length is the actual length, and the other length is your center to center lengths. So what I might do is in the custom name create an item called cut length, and the UOM is meters lowercase. That's quite important. If it's uppercase, it won't work. And drag and drop the cut length in there. Okay, so again, preview. hover over like a 55 meters in terms of length, 53, a little bit less in terms of cut length, and also a volume, which I said before isn't really used for structural steel. Now I'm here to show you the XNUMBER feature. So if we just scroll across, looking at my level 3 name here, as I said before, that 40 designates the kg, or the weight per meter, and there's my length. So one obviously multiplied by the other will give me my total weight, but I'm looking for that weight in tons. So I'm going to create a UOM, a T, again lowercase, must be in quotation marks if it's something you're typing in. I'm going to start by inserting a function called XNUMBER. XNUMBER, forgot the N. Open brackets. Again, this is very similar to what you do in Excel. And I'm going to drag and drop that level 3 name in. So XNUMBER open brackets. Then after I drag and drop it over, it's comma and then number 3. So the number 3 tells it to take the third number. So first, second, third, take the 40. And then I'm going to close my brackets. So that is taking that 40 from that string of numbers. And then I'm going to divide that by 1,000 to convert it to tons, because it's in kg, 40 kg, and I need to convert it to tons. So I divide it by 1,000 or multiply it by 0.001, brackets at the end and brackets at the start to complete that formula. Then once I've got that, that's the actual weight per ton per meter, I've got to multiply it by its total length. So again, that's a complete formula. I may have to go between map and definition preview and see that everything is okay as I do that. It's not showing an error, so I've actually constructed that correctly. If I put a bracket in the wrong place, if I did something incorrectly, I wouldn't be able to preview that. It would tell me that there's an error possibly in that field. So as I was doing before, multiply that function by its length. I'll take the length because it's a little bit higher, and I'll err on the high side. Now maybe click preview, click the little plus, hover over, I can see there's a weight in there at 2,200 tons. I know because I'm somewhat of an experienced quantities of air that cannot be right. It can't be 2,200 tons, that's a lot of steel. It's more like 2 tons, so there's something happening in there. And what's happening is, when I need to convert a length and I need to multiply it by something that's not a length, that's already designated as tonnage or a weight, it won't do it for me even though I put that units in there as millimeters. It will work when I'm going from millimeters to meters or millimeters to meters squared, but doesn't seem to work when I want to go from kg to tons, from tons utilizing a meter length. So I'm actually going to tell CostX, open the brackets and divide that length by 1,000 to change it to meters. So from changing it or dividing it by 1,000, I'm changing it from millimeters to a meter length. And now if I preview, hover over it, I've got a weight of 2.2 tons. Just to show you some advantages, if I have this mapping definition created correctly and automated in a way that it may apply to another folder or to another member. If I scroll up, I have some columns. Of course, the beams are attached to the columns in this regard. It's also in Commons frames there. And if I scroll across, I can see that my level 2 name is plate columns and my level 3 name similar, 610 by 210 by 40. So the size or the weight per meter is the same with the dimensions slightly different. Let's say, for example, I take my universal beams mapping definition, I right click it, I copy it, I scroll back up to my plate columns, and even though it's quite different in terms of its family name or its level 1 name, 2 name, 3 name and size, if it's set up correctly, I may be able to use it again. So right click, paste. So I've pasted what was in my beams into my columns. Everything is the exact same. If I click preview just to see that it works, plus, this time it's called plate name because now the plate name is the level 2 name and the level 3 name is, well, its size, and again it's different. hover over it. I've got a length, I've got a volume, I've got a weight at 2.14. Now I do know that's correct based on my lengths. I've done the calculations before. What is different here is I don't have a cut length. The reason that's the case is because I actually don't have a cut length here as a parameter, given that the length and the cut length are the same for the columns. A little bit more practice now with the XNUMBER function. So I'm going to scroll back and click the universal beam. I'm going to move down to my custom name 2. I'm going to create a custom name called painting. So I'm going to paint this steel, and my UOM quotation marks is going to be meters squared. I'm going to scroll across again, and I'm going to take again the same parameter, level 3 heading. Actually, before I do that, I want to set up my XNUMBER, open brackets, then take my level 3 heading. And this time I'm going to take the first number, 305, in that string of numbers. The reason being is because I'm looking for the height of that web, and that's the height. And I'm obviously going to paint either side of that web. So what I'm going to do is I'm just going to close that and multiply it by 2 for either side. Again, close the formula and divide it by 1,000 to change it to meters. So from millimeters to meters. It won't do that automatically because there's no units in against those numbers. Again, close the brackets, see if it's thrown up any error. Not yet. And now what I'm going to do is I'm going to take that function, I'm going to copy it, I'm going to click a little plus at the end of the formula, and I'm going to paste it. So I'm going to use the same function, exact same function again, right here, but this time instead of the first number I'm going to take the second number, and that will take that 165. And then instead of times 2, I'm going to multiply it by 4, being either side of that flange. So top, underside of top, then the bottom, bottom side of the bottom. So 2 times 4 divided by 1,000. Put brackets around that complete. This is a little tricky one now. Around that complete formula, and I'm going to multiply it by its length. Now this should work without dividing the length by 1,000 because it's in millimeters converting to meters squared. And if I click preview, click the plus, hover over it there, I've got painting 69.87 meters squared for those 4 members, each about 13.7 meters long. Take it from me, I've done it by hand, and that is correct. Now again, it takes a little bit of time to get used to that XNUMBER feature, but you can see how useful it could be. Again, if I wanted to copy that map and definition and paste it up here, preview my plate columns, I also have painting there of 110 meters squared, which is probably correct. Thank you.